So we said that we are going to have two different, let's say, monomers for nylon formation. They are going to have carboxylic acid monomer and amine monomer. Okay, amine is going to be the only thing new for you. Remaining are going to be the same monomers that same functional groups that you have studied already. Okay, only amine is going to be something new for you. So NH2 attached on both sides is basically amine. Okay, now this one has two carboxylic acid, one on right side, one on the left side. So we can say two means di. We can say this is a dicarboxylic acid. No need to remember its name, butane dioic acid. Just say it's a dicarboxylic acid. Okay. This one has two amine groups, so we can say it's a diamine or diamine, which is a second monomer over here. Now these two have to join together to make a polymer. How they can join together? For the condensation polymer, there is a condition. When they are going to join together, they are going to release a small water molecule as well. Only then they can join together. Okay, yes, Luna.
Miss, I do not understand the fact why is it called a dicarboxylic
That
acid?
means it has two amine groups on in one formula, you can say. NH2 on one on the right side, one on the left side. So two amines are there. So we
Oh,
can
okay,
say
okay,
it's a
okay. I
diamine.
got it.
And
I
this
got
one
it.
has two carboxylic acid, so dicarboxylic acid. Okay. Okay. Now how they're going to connect together? So the second condition I told you, the first condition is they don't have double bond, but they have functional groups. Now, to make the polymer, the other condition is they have to release a water molecule, only then they can join together. Now, if I just remove all these extra things so that I can show you how they're going to release the water molecule. Okay, one of the monomer will provide OH, this one, carboxylic acid one, and one of the monomer is providing hydrogen, this one. This OH and H together can make water molecule, which has to release out. Remaining C double bond O and this NH will connect together by a single bond, a covalent bond. So when we are going to make the structure again, side things is going to be same. Okay. This C double bond O is connected with the NH and the water has been removed already. Now, same thing can happen on both sides. Let's say I'm going to connect one more dicarboxylic acid over here, then one more amine on this side. I can connect more on both sides. What will happen? The same way, this carboxylic acid is going to, when it is going to connect from this side with anything, it has to remove this OH. So I can just remove this OH and then I can just extend the line, put a square bracket. Means from this side, this can continue. Same way, for this amine to extend on this side to make another bond on this side, let's say, it can attach more monomers over here. It has to remove this hydrogen, only then it can connect. So I will remove this hydrogen, this NH will come as it is, and then put the extra side bond with the square bracket. It means on this side, it can continue with the same way. So both sides, we are going to remove the same HOH that they are going to remove to make the water before, and then put the square bracket. It means this one is going to continue again and again on both sides. It can connect with more and more dicarboxylic acid and diamine.
Miss?
Okay. Yes.
So basically in the formula we should write um the this formula, okay? But for the water, we should write 2H2O because two
No.
water.
Water is going to be
Well,
one H2O, which is releasing from the center. We are not writing the sides one. Side one, we are just going to show that this can attach from the sides same way if something else is coming on the side. Right now, we are not sure if something else is coming or no. So we are not sure the water
oh,
is or no. It will
oh,
if something else will come on the on the sides to attach. But from the center, they are connecting. So when two monomers join, they just release one water molecule. If three will join the third one over here, they will release one more water molecule. So when three monomers connect, they release two water molecules. Four connect, they will release three water molecules. Like this. Yes, Judith.
So, miss, it's always water. There is no any other possibilities.
there is more possibility as well. Okay. If we don't have NH2 over here, we have something else. It can have other possibility, other removal as well. It can be HCl removed. It can be NaOH removed. But for your syllabus, we are limited till water for now. Okay. But later on, you will see that it can be any other small group as well. Whatever is attached here and here can remove. It depends whatever is the functional group. Okay. So anything else can remove as well. Let me give you a simple example for anything else. And I'm not making you confused for this. Let's say I have two monomers. I have the monomer number 1, which has the OH over here. Okay. I have the monomer number 2, which has Cl attached. Okay. So this monomer number 1 and monomer number 2 is going to connect together. Now this one is going to remove this chlorine, this one is going to remove this hydrogen, and the remaining thing can attach together. Now they are going to release HCl, not water. Okay, so this is giving hydrogen, this is giving chlorine, so HCl is going to remove, and this O will connect with the C. Okay, so it depends whatever is the functional group that will decide whatever is going to remove. For your syllabus, we are just checking those functional groups which are releasing water molecule. Otherwise,
Miss,
it can be any small group released, depending on the functional groups. Yes, Amreen.
As for every condensation polymerization, there will be a release of a water molecule, right?
There is a condition there will be a release because they have to connect together by breaking the bond. Now they don't have double bond to break. So they will break some structure from the main structure. They will just break the bonds with some small groups to connect, and these groups will make a small molecule.
Okay.
In the addition, they were having double bond to break. Okay, fine. But now they don't have double bond to break. So they will break some small molecules from the structure to connect together. Okay. So for the nylon, what you have to remember, they can ask you in the exam, what are the monomers to make the polymer nylon? You will say we need a dicarboxylic acid monomer, which will have COOH group on both sides. And you need a diamine or diamine as a monomer, which is going to have NH2 group on both sides. So they can connect together and they can make a nylon polymer. Now, nylon polymer is a polyamide. What is a polyamide? Let me tell you. So when they are going to make this polymer, they have this thing attached at the center, right? So this C double bond O, then N and H is a new functional group for you. It is a new functional group which is going to make another homologous series of organic chemistry. This functional group has a name, and the name is amide or polyamide. Okay. So amide means when there is only one of this, then we will say it amide group or amide link. And when many can come together, because when we are going to make a long polymer, this CO and H can come many, many times. Then we will say it's a polyamide. So C double bond O, single bond N, single bond H is a new functional group named amide. Yes, Luna.
Miss,
Hmm.
before didn't we said that NH when they combine together, Miss, in the before diagram, as you can see above, we said that it's amide.
Amine, when it
It's
is
amine, not
NH2,
amide. Okay,
not
I was
amide. Amine is
okay.
NH2. Amide is NH with C double bond O. Then it is going to be amide group. So amine and
Okay,
different, okay? Two different
Miss,
groups.
their names are so similar. You can't be confused
Yes,
with
yes.
them.
They both are new for you, amine and amide. So amine NH2, amide CONH.
So
Okay?
basically,
Hmm.
it's written poly, a brackets, amide. Or
Poly,
no?
simple you can write polyamide. With the bracket or without bracket, no problem. Because it's not the addition polymerization. For the addition, we were writing the bracket. Here you can say it's just polyamide. Nylon is a polyamide because it has C double bond ONH at the center when it is going to make a polymer. And it is made from two monomers, dicarboxylic acid and diamine. Okay, let's take one more example. Then the things will be more clear to you. And then I will talk about this structure as well. Okay, we will come back to this one. Before that, let's go to another example, polyester. Okay, now PET is a polymer. Okay, forget about polyester. I will tell you what is polyester. PET is another polymer. Its name is polyethylene terephthalate, the full name. Just remember PET. No need to remember polyethylene terephthalate, the full name. The short form is fine. So PET is another polymer. It's a condensation polymer. Like it's not addition, it's a condensation polymer. It is made from two monomers. Monomer number one is going to be dicarboxylic acid, means it is going to have COOH group on both sides. Monomer number two is going to be a diol. Diol. All word is from the alcohol. When we write the name of alcohol, we said that we are going to add OL at the center, right? So from the alcohol, all we can say two alcohols are there. So we are not writing di-alcohol. We can write a short form diol. Okay. So diol means two alcohol groups are there, two OH groups are there. So this PET polymer is made from two monomers. Monomer number one is dicarboxylic acid and monomer number two is a diol having OH on both sides. When they connect together, they are going to make this PET polymer. How? Let's check out the structure. Over here, this is the monomer number one, which has COOH. COOH means it is a dicarboxylic acid. Okay. This is the monomer number two, which has OH on this side. OH on this side means both alcohol groups, OH groups, means it is going to be a diol over here. So these two monomers now can combine together to make PET polymer. Again, they have to release water molecule then when they are connecting. Okay. Connect them from the center and then release the molecules from the center and side as well. Carboxylic acid will release OH from both sides. Okay. Alcohol one is going to release the H from both sides. This OH and H together is going to make a water molecule. Okay. This H and OH from the side we are removing just to make a bracket. Extend it. Okay. Now how they are making the bond? This C double bond O is going to connect with this O. Getting the point? From the first monomer, C double bond O will be connected with this O because H and OH will remove. So when this C double bond O is connected with the O, it will look like this. C double bond O connected with the O. Now this is what functional group? Do you remember? C double bond O with O attached on both sides with some carbon group is a which functional group? Yes, Lona.
Carboxylic acid?
Carboxylic is
No.
COH.
Okay.
COO
Similar.
on both sides with something
Alcohol.
not alcohol. Yes, Jude?
Last one, ester.
Non-ester.
Ester. Yes,
Miss,
Samreen?
I made it
Your
easy on
point of
her.
view?
Miss, my answer was also Esther.
Ester. Ester is something having C double bond O and O at the center, both sides something carbon. So yes, we got an ester bond at the center. We got an ester group over here. So just add the word poly with it. So this means this is going to be a polyester polymer. And this group over here is ester link or ester functional group. Okay. So we said the same thing when we were talking about ester, that ester is going to form from an alcohol and carboxylic acid. Remember? So yes, we have alcohol thing and carboxylic acid thing. So they are going to make ester polymer. Jude, you have any question?
No, miss, I just forgot to lower my hand.
Okay. So PET is going to be a polyester because it is going to form one of the monomer having dicarboxylic acid. Other monomer having two alcohol groups means diol group. When they connect together, they can release a water molecule and make a polymer, which is ester now or polyester. Okay. So same detail is given over here. This PET has a full name. In the exam, they can give you polyethylene terephthalate name or PET, but you don't need to remember this one. You can just remember the PET form. So it's a polyester made from dicarboxylic acid and diol, and ester linkage is going to be formed at the end. This PET is basically used to make synthetic fibers. Fibers are going to be made from this PET, and it also have an other name which is common for the exam. In the exam, they can ask you terylene. They can say PET terylene is the same thing. PET has another name, terylene. They can ask you, okay, tell us the monomers for terylene. So same monomer, dicarboxylic acid and diol. Or they can ask you what are the monomers for PET. So it will be dicarboxylic acid and diol.
Miss,
These
it's
names you have
already
to- Mhm.
Miss, it's already a short form of a word. You know, Miss, for us to remember oil rig, oxidation is losing of electrons and rig. Miss,
Yes.
PET is from the word pet. You know, the
Pet.
pets, the cute pets. Yes, so
Yes. So you can remember it, yes. So it's basically P is poly, E is ethylene, T is terephthalate, so PET or PET, you can remember. So it's used to make synthetic fibers, and another name for this PET is going to be terylene. Okay. So these two are condensation polymers. In the exam, they can give you multiple choice question in which they can give you, okay, PET is a uh, PET is an addition polymer, or maybe condensation polymer, or both. So you have to identify that PET is formed from dicarboxylic acid and diol, which is not having any double bond, so it's not an addition polymer, it's a condensation polymer. Same way the nylon over here that we said, nylon is made also by condensation polymer, not by addition polymer. Before that, we have seen polyethylene, polypropylene. Those were the examples of addition polymers. So this type of the question can also come in the exam. Okay. Now let's move to this structure that I told you, that we can also write it in a short way. Okay. What is this structure basically? It is basically, if you don't want to write the long structures like how many carbons are there or whatever, you have always a short way to write. Let's say in this first example, we are just concerned with the functional groups, which have to connect together and they have to release the water molecule or make a bracket, right? This central thing, C2H4, how many carbons and hydrogens are there? We are not concerned with this. We're not even talking about them. Same way, C2H4, we are not talking about this. We don't want to see how many carbons, hydrogens are there. We are just concerned with the functional groups. So what you can do, don't write anything over here. Just write a box that there is something at the center, a box. And same way over here, there is something at the center. We're not concerned about how many carbons, how many hydrogens are there. Just make a small box that there are some carbons, hydrogens in place of this box that we are not interested about. Okay, so if I make a box over here, it will look like this. So there is C double bond O, a box, then C double bond O, then NH, then a box, then NH, then C double bond O, box, like this. Over here, if I ask you to identify how many amide groups are there in this polymer, how many CONH amide groups you can see in this polymer? Amide group means this CONH. So how many amide groups are there? Any idea? Who can tell me? Samreen.
Miss 4, right?
4. There is one CONH over here. CONH. CO can come on right side, left side, no problem. Total CONH is here. There is another
Miss,
CONH
I
over
have
here.
one question.
So total 4 amide groups are there. Yes.
Miss, why is one box shaded and one is not?
One is shaded, one is not. This shaded box is coming from monomer number 1. Unshaded is coming from monomer number 2. Maybe this one has 2 carbon, this one has 4 carbon. We don't know. So both
Also
boxes
different.
are different,
So
having
different
different
than.
number of.
Oh, okay.
So when they're coming from 2 different monomers, we will make 2 different boxes. One shaded, one black, one red, maybe one shaded, one unshaded, like this. To just differentiate that this box is from monomer 1, then monomer 2, then monomer 1, monomer 2, like this. Okay, 4 amide groups are there. My second question is, if 4 amide groups are there, how many monomers has connected together to make these 4 amide groups? How many monomers are connected together? Yes, Luna, you're raising hand? No, okay. Anyone else?
Miss,
How many monomers are making this polymer to make 4 amide groups?
Miss, can you repeat the question again? I couldn't.
My question is, this is one of the polymer having total 4 amide groups in line, okay? How many monomers with the functional groups are how many monomers total are connected together to make this polymer? Yes, Amreen.
Miss, can it be 2?
No, no, 2 types are connected. Total monomers, how many connected?
So then it would be 4, right?
Mm-hmm.
Miss
Luna?
8.
8?
Miss, I was expecting also 4.
4. Very easy. Okay, Jude. I will ask from Jude and Wafia, then we will see. Yes, Jude?
Miss, I'm guessing 5.
Okay, Wafia, your guess?
5 as well, Miss.
5.
Oh, yes.
5 is the right
5.
answer, Jude and Wafia.
5. I didn't see the middle one. 5. It's 5.
You
I
can even
didn't
see the
see the middle.
boxes. 5 boxes means 5 monomers are there. Or in other words, as I told you, when 2 monomers connect, they make 1 amide group. 3 monomers connect, 2 amide groups. 5 monomers will connect to make 4 amide groups. Now, how you can identify that there are 5 monomers? Number 1, you can just see the boxes. 5 boxes means 5 monomers. Otherwise, you can see this is basically the monomer number 1, from which the CO is coming, means it was carboxylic acid. Then there is another monomer which was giving NH, amine, CO, NH, and then this one, its CO is hidden over here, maybe it is coming after that. So 1, 2, 3, 4, 5. 5 boxes are there, or 5 repeating units are there. Now this bracket you can see that I have made. It means the first monomer over here, this one is a dicarboxylic acid. Because when it has connected, it was having OH over here, and it was having an OH over here, which is removed now. Right? Yes, Wafia, your question?
Miss, I actually joined late because my internet was having issues, but Miss, I had a question.
Yes.
Could, instead of a dicarboxylic acid and a diamine, could a singular carboxylic acid and an amine join to make
They can join together
nylon?
as well. Yes, we are going to see that example as well. So if it is only single carboxylic acid or single NH2 group, they can join, but there is a condition as well. So we will see that example, okay? So before that, over here, if we are going to identify, they can give you this type of the structure, the same thing, and they can ask you to identify monomers from this. You can see, okay, COO is coming. C double bond O means it was having OH before. So it means it was a dicarboxylic acid. Same way, NH means NH is just coming from amine. So it means it was having HH at the start, which is basically released. This H and OH is released as a water. So this was a diamine. So if they are going to give you this whole structure, you can easily get the monomers back. How? Just make this one. Again, you can make the box, the shaded one. You can make C double bond O on both sides. Okay. Then just connect the OH back on both sides. So this is a dicarboxylic acid monomer which is joined together. Same way you can get the structure of diamine. Make the other box, unshaded one. Make NH. Whatever is given to you. Connect HH back, which has been removed before. So this is the other monomer, diamine. So from the monomers, you can connect them together by removal of water to make a polymer. From the polymer, you can just add the HOH back, make the polymers, the monomers again. And You can easily identify which monomers are connected together. Okay, yes, Papia.
So, Miss, is an amine or like a diamine a organic molecule?
It is going to be organic, yes. It has in place of the box, it has carbon hydrogens. So it is one of the organic compound.
Oh, okay.
Okay. If you just go back to its original structure, one of the example over here, this one, it was having C2H4 at the center. So it is one of the organic compound. So organic compounds can have carbon, hydrogen. Extra thing can be oxygen, nitrogen, fluorine, anything. So if carbon hydrogen chain is over there, it means it is organic compound. Yes, Luna, your question?
Miss, can you repeat what, like, for Wapia's question and your answer, like what you were
Vakya said
drawing?
that
Because
if this diamine is going to be an organic compound or no. So it is organic compound because it is ethane over here. C2H4 means 2 carbons. It is ethane. On ethane, 2 amine groups are attached. So it means it is organic compound having carbon hydrogens together. Okay. Okay. Now let's move. Everything is clear till here. Any question?
Miss,
If I this
I
type
meant
of the
about
polymer, yes.
the drawing, these blue
Yeah.
marks over there.
They will not ask you to draw this kind of the whole structure. Maybe they can give you this structure. They can ask you to identify the name of the monomer or make the monomer. So you can easily just name it or make it like this way. Okay. So we will practice the questions as well from this. Then it will be easy for you which type of the questions are coming. Let's move to another example. And okay, this one. Now I will ask you, you have this one of the polymer. You have to identify the monomers. First of all, tell me, is it a polyamide or a polyester? Is it a polyamide or polyester? Yes, we have Jude.
Miss, I think it's a polyester.
It's a polyester because polyester have C double bond O at the center, something attached. It can be this way or it can be this way. Or it can be on any side. No problem. Same thing. If this kind of the structure is there, it means it is polyester. Now, who can tell me how many ester groups you can see in this structure? How many ester groups you can see in the structure? Raise your hand only. Yes, Luna?
Miss 5, 6, because some are not completed.
The ones
5,
which are
6.
completed, you will not count them. Only count those
Really?
which are complete.
3.
Yes,
3.
3. So you can see one polyester ester group over here, other ester group over here, and third one over here.
Oh yeah, right. Because
3
when they're
esters
not
only.
completed, they're not
Hmm.
completed because
On the
they're
sides, if
more.
they're not complete, don't count them as the ester group. They have to
Okay.
join again with something else, but it's not a
Yeah.
ester group at that time. Okay.
Yeah, that's what I meant, that they have to
Yes.
complete.
If 3 ester groups are there, how many monomers are connected then? 3 ester groups are there. How many monomers are connected?
Miss, I have a question.
Wait. Yes, Samreen. How many monomers are connected to make these 3 esters?
4.
4 monomers are connected. So monomer is going to be one extra than the ester or amide groups present. 3 ester means 4 monomers are connected. Okay, before we move forward, yes, Varif, your question?
Miss, my question. Why isn't like in this structure, why there's no shaded box? Like shaded
Why
box.
there are total 4 boxes?
No, Miss, what, like there's 4 boxes, but like in the first one that like you showed us, there was some shaded box. Why there's no shaded box here?
I did not get your question. Your question is why
Miss,
the
in the yeah, in the first one you showed us that there were some boxes that were shaded, right?
No, that's your choice. See, it's just like we have to differentiate first box from second. First and third is same, then fifth is same. It's monomer 1, 2, 1, 2. Your choice. You can make red box, blue box, gray box, white box, shaded box,
Oh,
unshaded. Anything. Box is just telling that some carbon hydrogens are here. It can be any type of the box. You can make a circle, you can make any shape, just shade it.
Okay, miss,
Okay?
thank you.
It's like not fixed that we have to shade it or make any color. Let's say they are making this gray. Third one is gray, then fifth one will be gray. Second is white, fourth is white, sixth is white. So monomer 1, 2, 1, 2, like this. So any color, any size of the box you can make. Okay, so 3 ester groups means 4 monomers are there. Okay, now you will tell me, can we identify which 2 types of monomers are making this ester? Can we identify which 2 types of monomers are making this ester? And can we draw the structure of the monomers? Anyone? Which 2 types of the monomers are connected to make this polymer? And can we draw the structure of the monomers? Anyone? No? Okay, let me make the boxes. Maybe it will be easy to identify. Let's say this is the first monomer till here. Then this is the second monomer. This is the third monomer. This is the fourth monomer. Okay. This one and this third one is the same thing. Second and fourth one is the same thing. Okay. The first one, can you tell me the name of this? I have to add the H and OH back. That's it. So this one will get OH, OH. Because it's C double bond O means it's basically coming from carboxylic acid. This one will get H and H. Same way. Now can you identify the 2 monomers? This first monomer is what? What's the name of the first monomer? Wafia.
Miss, it's dicarboxylic acid.
And the second one?
It's a diol.
Diol, yes. Okay, so you have to just practice a little to identify these monomers back. So this is going to be a dicarboxylic acid. This is going to be a diol over here. If I just make the structure, it's a gray box, okay? Having C
Miss,
double
why
bond
a
O.
diol? Where did it came from?
We said that one of them is going to remove OH, other is removing H. So when we add H back, OH means it's alcohol. So it's a diol.
Oh, okay.
Okay.
So it depends on the
Monomer.
name.
It depends upon the name. So this is going to be the first monomer, which is a dicarboxylic acid. And for the second one, I can make it over here. It's a box with O and H will connect back. O, H will connect back. So having 2 alcohol means it is going to be a diol. So a dicarboxylic acid and a diol is basically making this polymer. So we can easily just get these monomer structures and their names back. Okay. Any question till here? Anything to ask?
Yes, Miss.
Yes, Mafia.
Miss, when we were learning like the terminology for the functional groups and stuff, we said that alcohols end in dash anol, right? So why isn't it dianol? Why is it diol?
Alcohols are basically, I just said this above, maybe you joined little late. Alcohol is basically, we end its name with OL. Rather than writing it dialcohol, we are writing a short name diol. Ol is for alcohol, right? When we write the name of the alcohol, we write OL at the center. Ethanol, butanol, propanol. So OL is coming from the alcohol. 2OH group means 2 alcohol. So we can write it dialcohol as well. But in chemistry, we have its short name always. Diol for dialcohol. So we will write diol in that case. Yes.
No, Miss, that's not what I meant.
What's your question
What I
then?
meant was, for the, you know how if we have to name an alcohol with, a specific number of carbons in it. So let's say ethanol. We don't call it like ethol. We call it ethanol. So why isn't
Yeah.
it dienol?
No. It's not dienol. It's like OL is only the name we want, and then we are adding di. Like it's the name given to two alcohol functional groups. It's not dienol, it's always diol. Okay, I got your point that we write butanol. So then why not dienol? So it's not dienol for us. Dienol is no functional group or homologous series. Diol is the homologous series, having two alcohol groups.
Okay, so it's fixed
The name,
basically.
yeah, it's the name given to them, diol only, not dienols.
Okay.